Hello there. In the connection of the series of video lectures on engineering mechanics, now we are going to be trying to solve one more problem when the rigid body is going to be having a rotational motion, right? So we need to find out different parameters like velocity, acceleration, the displacement and the number of revolution. These parameters we need to calculate in our process, right? So I hope you are able to following the regular video lectures so that your understanding capabilities are going to be little better, right? So that you are going to be prepared for unknown areas also. So here what we are exactly gaining from this one, here we are gaining the courage and how to solve that problem, right? So by giving the how to collect from the given data, that means we need to collect the data from the given parameters or the given situation, and then we need to prepare two unknown parameters from there. So in this connection, here is the problem. A flywheel has an initial velocity of 15 radians per second and a constant angular acceleration of 4 radians per second square. So in this case, can you see? So what is the flywheel here? The flywheel most of the time we are using in our automobile. So in this case what will happen when the fluctuations are coming from the engine, so it need to reduce those fluctuations. Suppose in the power stroke only the power is going to be getting, but remaining 3 strokes the power is required, we need to supply to the engine. Always we are thinking that engine is delivering the power. Yes, it is possible only in the 1 stroke. Remaining 3 strokes we need to supply to the engine. So then only the power stroke will going to be coming from that. So the excessive energy this flywheel is going to be stores inside in the form of the rotational energy, and it will going to be giving back when it is required to the engine. Okay, that's fine. The flywheel has initial velocity is going to be here radians. So that means I am going to be taking omega is equal to 15 radians per second is available, right? So that's going to be your 15 radians per second at a constant angular acceleration alpha is equal to 4 radians per second square. Then determine the number of revolutions. I need to be calculate the number of revolutions. It must undergo to attain angular velocity. Suppose this is going to be omega 1. This is the omega 2 is equal to 20 radians per second. And the time also required to achieve the 20 radians per second. So these parameters we need to be calculated. So I hope you are able to understand this part. So can you see here it is going with the constant angular acceleration. So it means that this object is fulfilling the uniform motion. That means in equal interval of time. So then it is covering the equal angular displacement. So then how could you calculate this n value? So as we know that we do have the different parameters are available, that's we are going to be using. So what is that one? Omega n is going to be available, omega, and alpha also available. So that I need to calculate the n value. Suppose when it is reaching to omega is equal to 20 radians, what is the speed and what is the time is required to reach this 20 radians per second. So from the given data, I am going to be writing that equation. What is that equation when an object having a uniform velocity or uniform angular velocity? That's going to be omega 1, right? Omega 2 is equal to omega 1 plus 2 into alpha at theta, right? So if you take the linear velocities, that is in the horizontal direction, the v is equal to u plus 2as, right? In this case, alpha is going to be your angular acceleration. Then I am going to be substituting in this equation. So I need to calculate the theta value. So then the theta is equal to omega 2 minus omega 1 by 2 into alpha I am going to be receiving. So it is going to be your 2 into alpha. Omega 2 is equal to 20 radians per second. Omega 1 is equal to 15 radians per second divided by 2 into 8. Sorry, this is going to be 2 into 4 because alpha is equal to. Then what is the value of this theta? So I got it around 21.87 radians I got it. Right? Once we have received the theta, then we can calculate the n value by using that equation. Now we have received this theta is equal to this value. So then the number of revolutions n is equal to, what is the formula we do have? That's going to be theta by 2 pi. So this we got it, omega is equal to 2 pi n. After the integration we got it. So that I am substituting here 21.87 by 2 into pi is equal to 3 point something is there, that I am going to be writing here. So the finally n we got in terms of RPM. So I got it around 3.48 and that I am going to be taking 4 RPM I can consider. So now we have received n is equal to 4 RPM. Now we need to calculate the time also. So how could you calculate the time? Because we do have omega 1, omega 2, alpha is available. So what is the formula we do have? So that's going to be, so the time required to reach the 20 radians per second, that's going to be omega 2 is equal to omega 1 plus alpha t, right? This is the object is rotating about angular, uniform angular acceleration. So omega 2, omega 1, alpha is available. Can you calculate the t value? So then the t is equal to omega 2 minus omega 1 by alpha, right? So what is the value from this one we are getting? That's going to be here 20 minus 15 by 4. 5 by 4 means I am getting 1.5 seconds. Can you see the time taken to reach from 15 radians to the 20 radians per second is equal to, that's 1.5 seconds it has taken, right? This way we are going to be calculating the n value as well as the t value. I hope you are able to understand the concepts whatever we have discussed, because it is related to the previous, the rotational motion of the rotation of a rigid body. If we have that concepts, these problems we can do, because these problems very widely we can see in our university exams as well as UPSC, the public service exams also we can prepare for this one. Engineering service exams or civil service exams also, it is going to be very helpful to you. Still, if you feel any confusion regarding these concepts, please put in the comment section so that I can reach you. So I hope you are able to understand the concepts whatever we have discussed, right? Thank you.